Hello guys, welcome to my channel Security Ninja. My name is Bohan. Today we are going to working on Squid game from TryHackMe, which is made by Russia Panda. It's a really great challenge, and a big shout out to Russia Panda for making this challenge again. And this challenge is rated as hard. It's definitely really hard challenge, but it will also same time teach you a lot of techniques. I really enjoyed it, either with or without hints. I really learned a lot. So I guess we can just jump in. So this challenge has 5 tasks. I guess you have 5 scenarios. Each of the scenario has one mailbox you need to analyze, which they are Microsoft macro. So we can jump right into the machine. So if once you start the machine here, we can see that we have this box here. So by the way, if you're not aware, this box is based on the REMnux, which is one of the Linux distribution mainly made for the reverse engineer or the malware analysis. So we have the mailbox here, right? So we have 5 doc file here we need to analyze, and let me show you guys the REMnux very quick. So the REMnux, based on the Sense cheat sheet, it can be used for multiple purposes. So we can analyze Windows executable, Linux binary, malicious code, some suspicious documents, network interaction, gather or analyze data, and some other analysis tasks. So in our case, I think if you look at here, we have the Microsoft Office files, which we have vmonkey, pico dump, OEVBA, and OEDump, which those tools are mainly what we need is OEDump and OEVBA and vmonkey. So OEDump is one of those tools that you can use to like doing the macro analysis, which it will extract all the macros, and you can see the streams in the macro. And for the vmonkeys, if you are not aware, so vmonkey is one of those emulators where you can use it to deobfuscate the code, right? So it's like a simulator emulator, right? So you use it to like a VBA emulation engine written in Python, designed to analyze and deobfuscate malicious VBA macros containing malicious Office files, right? So it's a really powerful tool you can use to doing the maldoc analysis. And we also have the tool here called OEVBA, which is similar to the OEDump, but it is used for like it's one of those tools in OE tools. So OEDump is one of those tools you can use to deobfuscate the VBA. So let's just getting started. So we know that the tools we need to use. So let's getting started for the first questions. First, attacker 1, which it's a quite big challenge for this. I think this one is the hardest. Attacker 1 is the hardest scenarios in my opinion. So the first question is asking for what is the malicious C2 domain you found in the maldoc where an executable download was attempted. So obviously this one you have to use OEDump, right? So I always like to use OEDump to gather some basic information about this malicious doc first, right? I guess you have to use oedump.py. So we see that we have certain streams here, right? So we see one of the streams is stream 8. This one is contains macro in there, right? So we have the macros in there, and if we check oedump, if we select the stream 8, and so dash s is means select stream, and you want to use dash v to dump the VBA file, right? So we see that here we have this highly obfuscated code here. It's not easy to understand. The purpose for this code is to trying to obfuscate and bypass security measures, or making the analysis more difficult. So we want to do so this code here is not obvious, but I guess we can look at each stream here, because there might be some hidden information in the stream, so we can look at one by one, right? So we know that oedump in the stream 8 is a macro, which is obfuscated micro code in there. If we look, we shouldn't use dash v here, but if we use dash s, so dash s is dumping the strings, right? So stream 1 we have Microsoft. We know it's a Microsoft 97 to 2003 document, MS Word doc, right? So let's look at what is in the stream 2. Stream 2 likely we have title here, we have the subject here. Those are likely the subject and title, right? So if we keep looking, we look at the stream 3. Something interesting here. We have the phone number here, right? So the phone number here is possibly the metadata for this file. So if we do a quick file on that doc file, we can see that we get exactly the same information from here. We have this phone number here, which is author's phone number. So obviously we have this phone number here, and we have this title and the subject here as well, right? So next one we can look at the stream 4, which is sorry guys, so just mistakes there. If we look at stream 4, immediately if you dump in the strings in the stream 4, you found here something interesting is this one. It definitely looks like a PowerShell, right? This is like a PowerShell, obfuscated PowerShell command here. We know that this is like base 64 PowerShell command with some obfuscation. So we want to like de-obfuscate it, right? So let's just open the cyber chef very quick in the REMnux and go from there. It's gonna take a minute, so just bear with me. So we got our cyber chef open here, and we can just put this part here because this is all is matter, right? So it's base 64 is what we're interested. So we can see that if we put the code here and apply on the base 64, it won't work because we have this kind of like brackets this bracket here, which is we need to figure out what that bracket is. It's look like some string needs to be replaced in order to getting the correct base 64. So if we're going back to the previous macro file we discovered in the office, we see that so those parts, this part is just like garbage. I think they're not useful, right? If we look at the so something interesting here we found is that we have this VB shell command here, which is running a cmd/c, right? So if you look closely, something here, you probably will not notice it at first, but if you look closely, you will see that this brackets, we have this alternative text plus this thing. So we have this replace function here. So we see that we have this brackets dash capital uppercase A here. So what if we by looking at this and going back to our cyber chef and doing a replace, right? So if we're doing a replace in our cyber chef, from replace the brackets with A, right? So we need to using the simple string. Immediately, if we replace it with uppercase A, as showing in the macro file, we see that we have this the obfuscated PowerShell here. So what we can do here is we can remove the no bytes, right? So make it easier to read. So obviously this is like a PowerShell here. We see that we have this C2 domain and the URL here. This is like a C2 domain for us, and we can also see that we have this executable was dropping. Right, we have these two domains here. One is this one, and another one is this URL. So I guess this URL is used for like downloading this executable and dropping on the machine, which we also have this CLS ID here, which is one of the answer we need later. So I guess at this point we can answer most questions in the attacker one. So obviously the first one, what is a malicious C2 domain you found in the maldoc where an executable download was attempted? So this one is the answer, right? So we say that we can find that domain here. And second question, what executable file is the maldoc trying to drop? We say the file we downloaded is this one, right? And next question, in what order is it dropping the malicious executable, or in what folder is dropping the malicious executable hint? So we have the hint here. So we have this get folder path, which I think if you just Google this, what this is, right? If you Google this very quick, you can find that this is actually program data, right? So with the percentage signs, so that is the answer for the question 3. And question 4, provide the name of the COM object the maldoc is trying to access. So let's just look at the hint very quick. So it's asking us to checking the CLS ID field. So CLS ID, we see that we have this CLS ID here, right? So I guess this is a CLS ID ID we need to find corresponding COM object name, right? So we can see that we have this abusing exported functions and expose DCOM interfaces for pass-through command execution and lateral movement. So it is one of those techniques to bypass detections, right? So it's an invasion techniques. So the answer for that one is a shell browser window, which is a corresponding COM object, right? So next question, including the malicious IP and the PHP extension found in the maldoc, we see that early, right? So this one is malicious IP is here, right? And the PHP code is this one, right? So that is the answer for the question 5, and we're moving on to question 6. We see that when we use file on this maldoc, early, we see that the maldoc, the phone number is this one, right? And doing some static analysis provides a type of maldoc. This is under the keyword auto open. For this one, we can use OEVBA or you can use vmonkey, doesn't matter, but in this case I will use OEVBA. So essentially OEVBA will be used to trying to deobfuscate this code, but in this case OEVBA will not help much because our PowerShell is hidden in the stream 4. So by just using this OEVBA, it will not help. So you have to like going through each stream one by one and figure out exactly what happened. Sometimes the automated tool, it will not always help. So we see that if we're looking at the hints here, it gives you a hint, use OEVBA, and it's asking us to looking at the keyword auto open, right? So auto open, we have the keyword auto open, and it's looking for the type is the auto exec, right? That is the answer for the question 7. Let's move into question 8. Provide a subject for this maldoc. So there's a multiple way we can do this, but since I already used a file on this maldoc, we can just getting the information from there. So subject is a West Virginia, is here, right? That is subject. And moving on to the next question, provide the time when this document was last saved. It's a tricky part because here you can see it's 2345. That is not the answer. It's a bit tricky. So for that one, in the OE tools, you will have the OE times, which will show you when was the last modified time for each stream, right? So if you use OE times, you can see that all these streams was modified at 23:45, 30 seconds, right? So that is the answer. Especially for the macro file here that we have this, right? Next question, provide the stream number that contains a macro file. We can just modify this. No, we can just read counting the total number of the macro, right? So we have the 8. We have the number 8 as like contains a macro file. We saw early, right? So provide the name of the stream that contains a macro. So it's this document. We see that early, right? So that is for attacker 1. I think attacker 1 is the hardest one because if you're not aware and if you're just going straight to the stream 8 macro, you're gonna be stuck on there for a really long time unless you use the. I stuck on there a long time because I didn't go through all the streams. I just like look at this stream and just focus on one part. So I guess sometimes you gotta focus on like when you analyze a maldoc, you're gonna going through all the streams, not just the stream contains a macro, because it might contains other informations in the other streams. So it's really important for you to going through all the streams in the file and to figure out what some other hidden information might hide in there, right? So that is for attacker 1. It's a really great one. Let's go into the attacker 2. Attacker 2 is relevant, easier compared to the attacker 1, right? So we can close that 2 window and we can clear our screen, right? So for the attacker 2, we can just OE dump. We use OE dump to getting some basic information first, right? Always forgot to put the .py, right? So we see we have the 4 macro file in there, right? So one of the faster way we can look at this is just use OEVBA, right? So it's basically it's just dumping all this macro file for you, and yeah, so you see that it's definitely obfuscated by just looking at this table. We already get a pretty good amount of information. We see here that we have base64 string. Some stuff in here is just really suspicious, right? We got some IOC here, which is a malicious domain, and some DLL here, and VBA stomping, right? So we have that information. We can say we can just answer the questions very quick, right? So first question provides the streams that contains macros. So for that one, you can go into the OE dump. We obtained early. It's a lot of lines here, so I have to like scroll up like this. So we have 12, 13, 14, 16 contains the macro. That is answer. And provide the size of the compiled code for the second stream that contains a macro. So it's so this one you have to like use the parameters for the OE dumps. So if you're not aware, for the OE dumps, going to the help page, right? So we see that we have one of these. I believe you need to use -I, right? So you need to print the extra information for that one. So because for the first one, for the original one, that one is the total size. We need to find the size for this compiled code, right? That contains the macro. So it's 138A67, which you can find by look at this, right? So it's the first part. And for the next question, provide the largest number of bytes found while analyzing the streams. Obviously, we can see that we have 63641 as the largest bytes in the stream 5, and we can see next part is find the command located in the font field. Make sure the reverse string. For that one, I guess it's asking you to look at the It's asking you to look at the um, yeah. So here you see that some of the code was being. So here it was like you're trying to download these DLLs, right, from that malicious domain, and the command was running those DLL was this one, right? This command it was using to run the DLL. Found the command located in the font field. I'm not too sure where that font field is because yeah, I think if you look at here, so we have this thing here, right? So it's like the order was being like was being reversed, so it's actually hint you to make sure to reverse the string, right? So if we go to CyberChef, right? So there's functions you can look at, right? Just to delete off this and reverse the yeah. So if you reverse the line, right? If you reverse the line here, you can see that this is actually the VB script was being running by the cscript.exe. That is the answer for the question 4, and for the question 5, provide the first domain found in the maldoc. I guess there's multiple ways. You can just look at the code here. This maldoc here, you can see that we have a bunch of domains here. We have this. So the answer is this one, right? So we can see we have this first domain. Download the www1.dll. So it's like a sequence, right? So www2, www3, www4, and yeah. So that is for like. So this one is the answer. This is the first domain contacted, right? Second domain. Second domain is here, right? So if we look at here, that is the second domain. Provide the name of the first malicious DLL. It retrieves from the C2 server. So www1.dll, right? So we can say it's in here, right? And the next one is how many DLLs does the maldoc retrieve from the domains? It's a 5, right? So we have the 5 DLL here. What provide a path where the malicious DLL are getting dropped into? So we see that the DLL was being run from this folder, which we know that it was being dropping to that folder. But if you look at here, it's also saying we are dropping it to that folder, program data, right? And how many seconds does this function in the maldoc sleep for to fully execute the malicious DLL? Which we can see that we have this sleep function here. It's with 15,000, but this is a milliseconds, so we want to convert it to the seconds, which you just like divide by 1000 and you will get 15 as your seconds, right? And the last question for this scenario is under what stream did the main malicious script use to retrieve DLLs from the C2 domain? Provide the name of the stream. We can look at it's asking for to retrieve the DLL, right? So we see that we have the OL, this part of the macro stream is used to retrieve DLL, so we see that this is a stream name, so macros/form/o. That is the answer for this one. Second attacker 2 is relevant, easier compared to attacker 1. But it's really fun. I really learned a lot. So let's move into the attacker 3. Right. So attacker 3. Attacker 3, we can see that we have few of this stuff we can see. So same thing, we can use dump, OE dump, right? OE dump, attacker 3 here. We'll have 3 macro stream contains a macro file, right? So this time I'm gonna do it a little bit different. We can run the vmonkey. So let's just put it into the emulator to see what's gonna happen, right? It's gonna take a second because it's trying to like simulate how this macro file would be run. So it's trying to parse in the VBA code here. It's getting a bunch of like, yeah, so you can see that it's actually running this this file and emulate it, right? So it's actually show you what it's actually gonna be run. So we see that it's really powerful tool for this kind of stuff. So we see we have a bunch of like entry points, it's auto open, and we have this yeah, so those are like you see that here, like kind of like a cert util, right? So it's been like obfuscated, but like if you just like replace couple like replace this u with this this variable here to here, it is like a cert util, right? So cert util is like you can either use cert util to like download the content from the internet, or in this case, I believe it's to copy the command or copy the executable, right? In this case, it's copy the executable as as the cert util used to copy the executable, right? So let's look at the questions. So provide the executable name being downloaded. Obviously, first one, if we just look at the actions here, so we have this bunch of like code right here. It was being like calling the cert util here, and this downloaded executable was being saved into the program data. So we know that the executable is 1.exe from this domain, right? So the final domain here is it is this one, is the where the we see that here we have used the cert util, download this executable from this domain and save it as a temporary file, and that is 1.exe is executable was being downloaded. A program is used to run the executable cert util, right? So we see that early here, cert util. And next question, provide the malicious URL included in the maldoc that was used to download the binary. So we see that URL, that domain was being, this domain was being serving the malicious 1.exe and was used to download it, right? What folder does this binary gets dropped in? There's a program data, right? And last question, what stream executes the binary that was downloaded? So for that one, you can look at the code you have here. So we know that we have A3, A4, and A10, three possible answers, right? So if we look at the what stream executes the binary that was downloaded. For that one, if we use, I guess we can use like OE OEVBA, I guess. So it's a little bit easier to read in this case. So we have it's asking for the A3 stream. A3 is the VB/T, right? That is stream name. So it's asking for which stream was used to download or used to execute the malicious executable. We see that we have this here. Right, we see we have the function here. So it's under this t.bas. T.bas, this one is like a VB/T stream, which is points back to the stream A3, which is used to execute this one.exe with the cert-util, right? So that is the answer for the last question here. So this one really fun challenge as well. Really good, really awesome challenge. Big shout out to Russia Panda here. So let's move into the attacker 4 here. This one. So there's a little bit. This one you initially, I think this one you have to like I use like just run the vmonkeys and the OEVBA, but reach out to Russia Panda, and seems like that's not intended way. So I went back to redo this attacker 4, and it seems like you have to like do it manually to find out the encryption key, which I think is much more fun compared to the just run the script, right? So we can run the OE dump first to dump the attacker 4. Right, we got this stream 7, we have this macro file in there. So we run the OEVPA, we can get the attacker4.doc. So we got this file here, right? So we see that we have a bunch of obfuscated the code here, right? So there's an interesting part here that if you look at the code closely, you see that we have an XOR here. This is actually a obfuscation that, well, if you're not sure about this, you can always like Google it, right? So obfuscate. So I came across this this blog written by TrustWave back to 2015. It's really interesting. I think this is like kind of similar to the challenge which they discovered this XORi was being used into to obfuscate this the VB script. So we see exactly here we have this XOR hex to string and hex to string. So we have two hex to string. So we can see another known obfuscation technique is XORing the string with a predefined key. The example below is the obfuscation of a URL link to the malware executable. In this example, this string here is the obfuscated URL, and this string here is the key. So we know that. So if you read that link here, I'm not sure why my connection lost, but we're back. So if we read that trust wave block, we know that this one is actually the data and this one is the key, right? So we can, so in this case we know what to do, right? So we can going back to for the questions we have here. So provide the first decoded string found in this maldoc, which will have this sub auto opens. We have this auto open here, and we see the first obfuscation was happening right here, right? So we can use like a cyber chef to trying to like deobfuscate it, right? So we put right here. Since we have one of this text to string function there, so I'm assuming this is like text hex. So you want to convert to the ASCII, right? So we want to use hex from hex, which convert to the ASCII, and we want to put the key in there, right? So XOR. You will have the key is the number here, right? This one is also the hex value, so you want to choose the hex as your key format, right? So we see that is ms xml2.xml http. So it's making a http connection, so we know it's doing some like a network connection. Potentially it's downloading some malicious executable to the machine, to the victim, right? And the second question is provide the name of the binary being dropped. If we look at the hint here, we have the manually on XOR using the key you found here. So if you get this answer from the vmonkey or the if you getting this answer from the vmonkey, I don't think the answer is that one, because I believe Russia Panda changed the answer later. So we have to figure out the answer manually from the XOR. So I can show you guys where to find it. So if we scroll down to the bottom here, we see we have this XOR hex value here, right? So if we just like copy it to copy the key as well, right? It's potentially is that one. So we see that we have this executable here as the downloaded executable, which the answer is different because I'm not sure. DYIA, yeah. So I believe this is the answer for the executable. You can find it this way. This way is the intended way you should find this executable. So if you're looking back to provide a folder where the binary is being dropped, it's a temporary folder, right? So you want to look at the other obfuscation here. So you just gotta be like decode them one by one, right? So we can see we have where's my so we have that, and then we gotta use the decryption key here to decrypt it, right? So that one is also another executable, but we gotta find the temporary folder. So for that one, if you just like run vmonkey, you can also get the answer for that one. If you don't want to like manually decrypt this, right? So But if you just like look at this, so for this one, I'm gonna have like a bit patient with this, because just be patient. You gotta like decode it one by one, right? So here we have, this one is a shell application here, right? So yeah, let's just run the VMonkey here, because there's just too much to like actually to look at. I think let's just run the VMonkey here because it's faster, right? So just want to show you guys where to find the temporary folder. So if you look at the VMonkey, it will like dumping all the information for you. It's gonna take a little bit because this file is relevant big, so just gotta have patience. Let's see what's the last question. So last question is also looking for this bin file, right? So we see we already got this bin.exe here. We see that the bin.exe, you can find this either through the XOR decode, like we did it earlier manually, or you can just read it from here, right? If we scroll down, we can see that we definitely can have some other information will be dumped here, right? So we have this file was being written to the temp folder. Yeah, so here we have the temp folder. So that is the answer for this for the third one, right? And the provider name of the second binary is so we know that is bin.exe, but you definitely can like looking at the XOR and just by like decode all the XOR strings and find the answer. But I just feel this way it will be faster. Yeah, so you look at here, we see that we have this file here, but this one is different compared to the one we had earlier, because yeah. So that is for the attacker 4, which is pretty interesting because you can see that XORing was being used here to obfuscate the code here. So let's move into the next question. Attacker 5, which is much more interesting, I think. This one is for like a Cobalt Strike shellcode deobfuscation and analysis, right? So let's just getting started with attacker 5 here. So let's just pass this first let's just do some like analysis first here, that we can see OLE dump. So OLE dump, we have the 3 streams here, right? So this one is the 3 macro file, right? So in order to find the caption, you're gonna be like just reading just going through each streams and dumping the strings by using the uppercase S, right? So let's just do that very quick. So we're going to the stream 1, nothing there. Stream 2, some basic information, right? Stream 3, email address, right? Sales department Texas at outlook.com. Stream 4. Stream 4, there's some data in there, but there's nothing interesting there. So let's just going through the next stream. Stream 5, embedded object, nothing there. Stream 6. So we see that in the stream 6, some interesting thing here. It's this is caption we found here, like a Cobalt Strike is everywhere. That is true actually. Cobalt Strike is being used really often these days, so by the malicious threat actor. So that is the first question: is the Cobalt Strike is everywhere? So you know that you're dealing with a Cobalt Strike maldoc. So let's move into the next question. So I'm gonna just use a vmonkey to dumping all the code here, right? So once we dump the code here, we have this PowerShell, obfuscated PowerShell right here. We can put it in our cyber chef to doing some deobfuscation, right? So it's a bit tricky, this part, so you definitely you gotta know the stuff. So I'm gonna delete this. Delete this, and this is like a base 64. If you look at this encoded command, it's like accepting base encoded base 64, so you know it's a base 64. So you gotta use base 64. We got some progress here. We see there's we gotta remove some no bytes, right? So no bytes removed. We see that this was being compressed. It's like a base 64 compressed code here, right? So we're gonna like extract this out. H4S means the gzip. So gzip. So we're gonna usegunzip to unzip to like unzip it, right? So we see we have the gzip stream. So we know how to decompress this, right? So let's decompress this very quick. So we're gonna leave the base 64 there because it's a base 64 compressed string. But what we're gonna do here is to use compress gunzip, right? So we have this code. Once we unzipped it, we got this code here, and we see this part. It's another like base 64 string here. This one is actually the shellcode, encrypted shellcode that used by the Cobalt Strike to establish a C2 channel to the victims. So we have this encrypted code here. Encryption algorithm here is like a looping through this malicious shellcode and apply the XOR 35. So XOR 35 is a decryption key we're gonna use. So let's just copy this. Let's just copy the code here, right? And the cyber chef just like let's just copy the shellcode there, right? So and we gonna so we have this base 64 there, but one thing we missed is we saw earlier that is XOR 35 encrypted. So we're gonna Since it's like a decimal, so we're gonna use decimal, and we immediately see there's an IP address in there, and we have the user agent here, but other data it doesn't make any sense, right? So this is actually a shellcode. We gotta like extract it to our local machine to analyze further. So we're gonna download this. Save just like a default name download.dat is gonna be fine. So save the file, and another tool we're gonna use in this scenario is shellcode debugger. If you guys never heard about, it's a tool used for like debugging the shellcode. If we look at the help page, yeah, I think you gotta use the shellcode debugger C. Let's see if you can use this. Doesn't allow you to like, yeah, so trying to look if I can like look at the help page -h. Yeah, so that's a /h. So what we're gonna use here, we're gonna use the shellcode debugger. Yeah, so it's like it gonna be help to analyze the shellcode. So we're gonna use /f to load the shellcode from the file, and we're gonna use /s -1 here. So because we're gonna use like unlimited steps to run this shellcode, so let's do that. So let's just run the sc debugger c /f here. Let's just like put our downloaded shellcode in there, and what was that? So it's that -s and -1, right? So we see here that we have this this code right here, that we have the virtual alloc. So those are like a 132 API. If you guys know the where's the load library A, internet open A. So those are like a 132 API used to establish network connection. Virtual alloc is pretty common in the malware to allocate the memory space to loading the malicious code in there. And HTTP request here, open and send, is to making a HTTP request to the remote malicious IP. So this IP is actually a Cobalt Strike IP. We can look at the shutdown, right? So we can just look at it. It's based in Ukraine, Kiev, right? We didn't see the 8080 on there anymore, but if we look back to the history, I have a shutdown account on there, I believe. Yeah, we can see 8080 was there before, so it's back to last year. So this server was used by Cobalt Strike to hosting the server and their infrastructure. So let's going back to the answer. So XOR 35, the key we saw earlier is 35, and provides 32 IP address of the Cobalt Strike server. We saw the IP is here, and user agent we found here, right? This is a user agent, and for pass is here, it's obvious. Port number 8080, right? So we see the port number here, and the first two APIs is load library A and the internet open A. So that is all the attacker challenge. Squid game. It's really fun. definitely like learned a lot from this challenge, and it's quite a bit hard, and learned a couple new tools. Again, big shout out to Russia Panda again for making this challenge, and I'm looking forward for more challenge from Russia Panda and from TryHackMe. And thank you guys for watching this video, and see you guys in my next video.